Welcome to another cyclical integration example. So in this example, we are going to evaluate the definite integral from 0 to pi over 2 of e to the 2x sine of 5x dx. So again, the first thing we want to do is find an antiderivative. Again, I'm going to swap my trig and e to the function. So I'm going to rewrite this as integral of sine of 5x times e to the 2x dx. You can pick either sine or e to the 2x as your u. Again, I'm much less likely to make an error with the positives and negatives when it comes to differentiating sine and cosine, so I'm going to use that as my u. So we have sine of 5x is my u, e to the 2x is my dv. Differentiating down the left-hand side, we'll have a 5 cosine of 5x, followed by a negative 25 sine of 5x. I'm going to stop here because I'm going to wind up with my repeat row immediately here. E to the 2x goes to 1/2 e to the 2x, followed by 1/4 e to the 2x. So I'm going to again stop here. This is a repeat row, so we stop. We take our positive diagonal first product, second diagonal, we do the negative product, and we will add on the integral of that last row. So we have the integral of sine of 5x times e to the 2x dx is equal to, we will have a positive sine of 5x times 1/2 e to the 2x. Then we subtract off 5 cosine of 5x times 1/4 e to the 2x. And we add on the integral, which is a negative 25 sine of 5x times 1/4 e to the 2x dx. Once again, I'm going to set A, capital A, to be the integral I'm aiming for. So the integral of sine of 5x e to the 2x dx. We wind up with capital A is equal to, on the right-hand side, we have 1/2 times sine of 5x e to the 2x. Then we have minus 5/4 times cosine of 5x e to the 2x. Then we have minus 25/4 times the remaining integral is just our capital A. Right, we're left with the integral of sine of 5x e to the 2x dx, which is what our A was. So from here we can solve for A. And we are looking at 25/4 plus 4/4 will be 29/4. A is equal to 1/2 sine of 5x e to the 2x minus 5/4 cosine of 5x e to the 2x. Therefore, A is equal to 2/29 sine of 5x e to the 2x minus 5/29 cosine of 5x e to the 2x. So we have our integral of e to the 2x sine of 5x dx is equal to 2/29 e to the 2x sine of 5x minus 5/29 e to the 2x cosine of 5x plus c. So far we have found the indefinite integral, or found all the antiderivatives. Next up, we need to take the definite integral from 0 to pi over 2. So our second step is to apply the fundamental theorem of calculus. To find the definite integral from 0 to pi over 2 of e to the 2x sine of 5x dx. So this definite integral from 0 to pi over 2 of e to the 2x sine of 5x dx is equal to, we just found 2/29 e to the 2x sine of 5x minus 5/29 e to the 2x cosine of 5x, and then evaluated at 0 and pi over 2. This becomes 2/29. I'm going to factor out our e to the 2x. So we have 2/29 times sine of 5 pi over 2 minus 5/29 cosine of 5 pi over 2 all times e to the pi. And we will subtract off 2/29 sine of 0 minus 5/29 cosine of 0 all times e to the 0th. Sine of 5 pi over 2, that's equivalent to sine of pi over 2. So this equals sine of pi over 2. And sine of pi over 2 is just 1. Cosine of 5 pi over 2, again, that's the same thing as cosine of pi over 2. Cosine of pi over 2 is, of course, 0. Sine of 0 is 0. Cosine of 0 is 1. I would definitely refamiliarize yourself with evaluating sine and cosine at your basic values on the unit circle. So we are looking at 2/29 times e to the pi. Then we have minus negative becomes plus 5/29 times e to the 0th, or just plus 5/29. Again, this is how we go about performing cyclical integration by parts. If you recognize that you have a repeated row, you stop there. And by repeated row, you just need the product to be repeated. Stop there, then use algebra to solve for your integral. If you need to do the definite integral, then it's just your usual apply the fundamental theorem of calculus from there. Right, in the next videos, we will see some special cases or special functions that we can use integration by parts to find the integrals of.